Hello friends, welcome back to the channel, and in this video we are going to learn how we can convert frequency domain into time domain. And in the previous video we learned how we can convert time domain into frequency domain. So in the previous video we learned discrete Fourier transform using decimation in time fast Fourier transform, and in this video we are going to learn inverse discrete Fourier transform using the same decimation in time fast Fourier transform. And I hope you know what is the meaning of decimation in time. Decimation in time means the time domain sequence will be in bit reversal order. So here the output will be in time domain, right? So the output of the entire butterfly diagram should be taken in bit reversal order, and the input is in frequency domain, right? So the frequency domain will be in normal order only. So this is the sequence that I have took from the previous video, as we converted the sequence from time domain to frequency domain. So this is the result of the frequency domain. Now I will convert this frequency domain sequence into time domain again. So first I converted it from time to frequency, and now again I am converting it from frequency to time. So that is how we learn things, right? So now let's start the process. So I hope you know that here we are going to take capital N equal to 8, that is 8 point DFT, I mean inverse DFT using DIT-FFT. So we will require 8 lines, straight lines over here. If you have saw my previous video, then you will know that what is bit reversal order. If you have not watched that video, then please do that. And I will just list down those indexes at the output. So the first one is x of 0, then we have x of 4, and in the last we have x of 7. So these are the indexes for the bit reversal order. So the first thing is that the input should be in frequency domain and the output is in time domain. It should be in normal order, the indexes, and here the indexes are in bit reversal order. Now let's move on to the butterfly diagram. So in previous video we drew the butterflies independent on the right hand side, and as we moved towards the left hand side we overlapped the butterflies, right? But here we have to do the opposite thing. We will start with independent butterflies on the right hand side, and as we move towards the left hand side we will overlap the butterflies one on another. And let's draw that butterflies quickly so that your time will not get wasted. So these all are independent butterflies. This is the head and this is the tail. The head always contains 1 and the tail always carries -1, and the data flows like this. Now let's draw the middle butterflies. So this represents two butterflies. This is the first butterfly, and over which there is another butterfly overlapped. This is the head of the butterfly, first butterfly. This is the tail of the first butterfly. This is the head of the second butterfly. This is the tail of the second butterfly. So head always contains 1 and tail always contains -1. Now for the remaining lines we will copy paste the same thing. Now let's draw the final butterflies over here. Here all the butterflies will be overlapping one on another. So let's draw it quickly. Here I will be leaving 1, 2, 3, 4, 3 lines, and after that we will be joining the butterflies' legs and hands. So this represents one butterfly. This is the head and this is the tail of the butterfly, and the data flows like this. So this is the giant butterfly. Now over on this butterfly we will overlap more butterflies. This is the head and this is the tail. So I hope you have understood till this point. Now the fourth thing that we need to consider over here is W8 and power NK values, right? So here we will mention all that W8 power NK values on the right hand side, I mean right leg of the butterfly. In previous video we did that on the left leg of the butterfly, so as it is inverse discrete Fourier transform, we will take it on the right hand side. So here it will start as W8 of 0, and here we will have W8 of 0 and W8 of 2, and here we will have it in a sequence. Now the thing that we need to take care of is these all values are I mean in previous video we took it as W capital N of NK, right? But now we need to take minus NK. That's why these all values are minus 1, minus 2 and minus 3. So this is the thing that we need to consider. Now the last thing that we need to take care of is the final solution. Final solution should be multiplied by 1 by n, that is 1 by 8. So the final solution should be multiplied by 1 by 8. I guess you are able to see the sketch. And that's it. These are the things that we need to take care of while drawing the butterfly diagram. Now we will compute the solutions one by one for each stage. The data will flow like this, and we will maintain the solutions on another paper for stage 1, and for stage 2 also we will maintain a solution, and for the final stage, that is the real solution, we will maintain a table on another paper. So I already have written these values over here, that is the input value. After that, as we get the solutions, we will note it down on the butterfly diagram. Now let's start the process. So here I will take a black pen. So first thing, on the 0th index we have 12, so 12 will travel like this, and I will write it over here, 12 plus, and after that we are getting the next thing from 4th index, that is 0, so 12 plus 0 will be 12. And now for the next one we have 1 minus 2.414j, and the next thing we are getting from 5th index is plus 0.414j, so it will give us 2 minus 2j. Now the next thing over here, on the third line we are getting 0, and we are getting it from 6th index, which is 0, so it will be 0 only. And for this line, 1 minus j, 0.414, plus we are getting, for this line we are getting it from 7th index, as you see, 7th index. So we will add up this 1 plus 2.414j, so we will get it as 2 plus 2j. Now for the 4th index, we will first calculate the things for the until here, and after that we will multiply with the values over here. So here I am getting x of 4, that is 0, and the other thing I am getting from the 0th index, that is 12. So 12, it will be equal to 12, and if we multiply it with 8 of 0, that is equal to 1, so that will also give us 12. And as this is getting multiplied by minus 1, so we will multiply this by minus 1, and it will get equal to minus 1 minus j 0.414 and plus 1 minus j 2.414, and 1 will get cancelled, and these two will get added up, and we will get minus 2.828j. Now let's go to the 6th point. Here we have 0, and we are getting that from 2nd index, right? So we will add that 0, and if it is getting multiplied by -1 also, it will stay as 0 only, so the final answer is 0. And for the seventh line we have 1 plus j 2.414, and this is multiplied by -1, and the other thing is coming from third index, that is 1 minus j 0.414. so this is -1 minus 2.414j plus 1 minus 0.414j, so 1 and 1 will get cancelled, and here we will get minus 2.828j. So we have got the values, and till this point we got it as 12, and here we got it as 0, and till this point we got minus 2.828j, right? Sorry, we got it in reverse order. This is 2.848j. At this point we got minus 2.28j. Now let's multiply this and this with these values. As this 0 is multiplied with anything, we will get it as 0 only, so let's note it down over here. It's a 0, and here if 12 is multiplied by 1, we will get 12 only, but we need to multiply these two things. Now let's do that on this separate paper. So here we have minus 2.828, right? This is 828, and this is multiplied by 1 by root 2 plus j into 1 by root 2. So I'll show you this calculation in Calc. So see, if I divide this 2.828 by root 2, so we will get the value as 1.999 something something. So we can consider it as exactly 2. There is no problem in that. So we will consider it as 2, and we will get minus 2j plus here we will get minus 2j and into j. So this will be minus 2j, and jj will get multiplied, so we will get -1, so it will convert it as +2. So we got is 2 minus 2j. So here let's note it down. Here we got 2 minus 2j. Now for this term we are multiplying 8.82j with minus 1 by root 2 plus j 1 by root 2. So here we will get this as 2 and j plus it will get minus 2j and one more j will be there. So this is 2j minus 2, and this is j square, so this will give us -1. So we will get 2j plus 2. So finally we got 2 plus 2j, right? Now this is the final value for this stage, 2 plus 2j. Now let's note it down for the upper lines. Here we got 12. Perfect. Now let's move on to the third stage calculation. Here for the first butterfly, 12 is traveling like this, so 12 plus, and we are getting 0 from here, so it is 12. For this line we are getting 2 minus 2j, and plus from another line we are getting 2 plus 2j, so these will get cancelled and we will get 4. For the next line we are getting 0 from here, and from first index it is 12, so we will get it as 12. And for this line we are getting 2 plus 2j, and from here also it is getting multiplied by -1, and from here we are getting 2 minus 2j. So we got 2 plus 2j and 2 minus 2j, so we will get it as -2 minus 2j plus 2 minus 2j. So these two will get cancelled and we will get -4j. Now let's move on to the next butterfly over here. So again, if we take 12 and 0, we get 12. From here we get 2 minus 2j, and from here we get 2 plus 2j. Again we will get 4. So this is 12, this is 4, and for this third line we get 0 multiplied by minus 1, 0, and plus 12 we get 12. And for the last line here we got minus 2 minus 2j, because it is multiplied by minus 1, so we'll get minus 2 minus 2j, and added with 2 minus 2j. So minus 2 minus 2j added with 2 minus 2j. So 2 get cancelled and we get minus 4j. Minus 4j. And let's note it down the values over here also. So we got it as, and let's note down over here also. So we got 12, 4, 12 and minus 4j. So now let's multiply these two terms with the w value. So this is equal to 1 only, but this is equals to j, this is equal to 1, and this is equal to j. So if we multiply anything by 1, it is the same, and if we multiply minus 4j by j, so jj square will be minus 1 and it will convert it as plus 4j. Here also it will be the same, and here we will get same thing, plus 4j. So let's maintain it over here. So we got plus 4j, here it is 12 and here it is plus 4j, and here sorry, it is just 4, not 4j, it is just 4. Okay, so we got it this as 4, and yeah, these all are fine. Now let's compute the solution for the final stage that we have over here, that is in time domain. And before that we have to multiply it all by 1 by 8. So now let's start the process. From here 12 is coming, 12 plus, from here we got 4, it is 16, and if it is getting multiplied by 1 by 8, then we will get it as 2. And for the second in line we have 12, and it is multiplied by minus 1, right? So we get minus 4, and then 8, and multiplied by 1 by 8 we get 1. For the next line again same thing, 12 and plus 4 we get 16, and multiplied by 1 by 8 we get 2. And for here also we will get minus 4 and plus 12, minus 4 and plus 12 will get 8, and multiplied by 1 by 8 we will get 1. In the same manner all of them will come as 2, 1, 2, 1, 2, 1. So we have the final value here, 2, 1, 2, 1, 2, 1 and 2 and 1. So this is the sequence for the time domain signal. Let's note it down in a clear manner. So the time signal that we have over here is, for 0th index we have 2, for first index we have 2, for second index we have 2, and for the third index we have 2. Now for the fourth index we have 1, and the sixth index is 1, seventh index is also 1, and the sixth index is also 1 and seventh index is also 1. So we got the final sequence which is in time domain. So this was the original signal that we took in previous video. So after converting into frequency domain we got this sequence, as you can see, this sequence, and after converting it into time domain we got the original sequence again. So this is how things work here when we are doing Fourier transform or inverse discrete Fourier transform, right? So that's it. I hope you have understood whatever I have explained in this video. Let's just do a small recap. First thing that we need to consider in the diagram is input should be in normal order, which is in frequency domain. Output should be in bit reversal order, which is in time domain. The output should be multiplied by 1 by 8. the butterflies should start independently on the right hand side, and it will overlap if we move towards the left hand side, and these W values should be on the right leg of the butterfly. And also the thing that we need to consider is we need to take Wn power minus Nk, not plus Nk. Perfect. These are the things that we need to consider, and it is easy to do the computation of the solutions if we maintain the values for each stage in a separate paper. And if you maintain the values in a separate paper in a clean manner, this is a little bit clumsy. If you maintain it in a clean manner, the examiner will get impressed and they will give you good marks in exams. So yeah, we have done everything perfectly. Literally it took like 3 times for me to record this entire solution. Every time it got wrong, but yeah, finally we got the correct solution. And if you like my videos and explanations, then please subscribe to the channel and press that bell icon also. And yeah, don't forget to press that like button also. It will motivate me a lot. And yeah, thanks for watching. I'll meet you in next video.